Everyone. This has been awesome. I haven't seen sweatpants all day, so this is really exciting. My name is Sherard, and this is Marius, and we are going to talk about machine learning for the greater good. I currently work at Red Hat. I'm the director of AI services with engineering. And Marius?
I also work for Red Hat. I'm a chief architect in the financial services team at Red Hat, focusing particularly on AI and how we help financial institutions use it.
Sorry, you go ahead.
So this is why I have collaboration, which is the topic of today's talk. What we're going to talk about today is kind of take a little route towards away a little bit from the algorithms and talk a little bit about a bunch of community efforts and how different institutions come together and work. We're going to talk about why they do it to build better machine learning solutions. We're going to talk about a project called OS Climate. This actually, and the project called the Enterprise Neurosystem, which are reflections of this. So, without much further ado, and before handing it over to Sherard, to talk a little bit about how this happens, why do these institutions collaborate? Like, why do you have, why do they collaborate, for example, between competitors? Why do they share data when there's a lot of concern around that? Like, they try to protect their data. That's their asset. The reality is that we have problems that go beyond competition. We have problems of general interest. How do you build models, for example, for risk management that take into account the climate, which is what we're going to see next. These types of problems are both, requiring a lot of data. They're requiring a lot of effort. So on the one hand, you want to eliminate duplication. On the other hand, there is no winner if someone gets it wrong. Like the industry is in particular, these industries are very averse to the fact that someone really does something really, really bad, and it's bad for everyone. So, reducing the risks of poor data quality and duplication of efforts, and having a strong governance to address ethical concerns, I think are key pieces here. I'm handing it over to Sherard to talk a little bit about how does happen.
When you talk about solving problems that require many entities coming together, a lot of times we hear companies coming to Red Hat because we have a history of collaborating in a transparent and open way. And a lot of times when you look at what Red Hat has done, it's providing a series of things that these open source collaborative communities need. The number one thing is governance. You get a group of people together, they don't always get along. So you have to define governing strategies, you have to put together steering committees. We've done this for a long time, so we provide a lot of value and a lot of insight to help communities do that. The other thing is how to collaborate. When you're talking about not just the code, but the data, all kinds of information, it has to be done, in a transparent way, and we provide some guidance there. And then ultimately, to me, the most important part of this is, as you're collaborating, who owns what? What does the licensing look like? If I'm developing new source code, or if I'm developing new data sets, then there has to be a level setting on what happens from a licensing perspective, how is that shared, what can you do with all of that information. And so that's kind of where Red Hat comes into the fold when we're talking about communities like OS Climate, which combats climate change, and when we talk about Enterprise Neurosystem. It's important to have that experience and that grounding so that everyone understands how to operate. Next slide. I'm going to first talk to you about our open source initiative that we've been working with a lot of different institutes on, which is OS Climate. And Red Hat was brought in, and it's actually a number of different institutes that I'll talk about, but we were brought in because we wanted to look at ways in which we could build a common infrastructure to be able to help combat it. And so if you look at OS Climate, their goal is to use open source as a way to combat and do climate smart investing. First, talking about the problem a little bit. If you look at the Paris Accord, the goal of the Paris Accord is by 2030 to cut CO2 emissions by 50%, by 2050 to have a net zero, and by 2100 be net negative. In order to do that, as of today, it will take over $1 trillion per year of investment to get to that point. And if we naturally, organically let companies figure out how to do that, that's not going to happen. There's not enough investment today to push them towards closing that $1.2 trillion gap. Next slide. And so if you look at the current capital markets, one of the ways you can get them to do that is by steering where the investments go. The capital markets today represent over $100 trillion worth of investment decisions. And within those investment decisions, we have the power to either increase or decrease the CO2 emissions. We also can align or benefit from climate-aware decisions. And so you have organizations in asset managements like the Net Zero Asset Owners Alliance, which they're growing in their portfolio. That means there's a lot of attention being paid to how do we invest in companies that will do the right thing to get us more towards that Paris Accord and decrease our CO2 emissions. For OS Climate, the approach here is an interesting one. When I first heard it, I was very curious as to how open the whole paradigm of open source can help out. But as we dove into it a little bit more, it started to make sense. The first thing they want to do is to redirect the capital from climate risky portfolios into low carbon, high resilient opportunities. What does that look like? It means if there are companies that are doing things that harm the environment, reduce those investments and push them towards companies that are doing more about the environment. And then it's also, how do we look at the different sectors? How do we build a common platform to analyze all that data? And how do we do it out in the open? The out in the open part is why it was decided through the OS Climate Initiative to put that as part of the Linux Foundation. It had to be some central organization that's completely transparent because there are critical decisions that will be made. I'm talking in this, you'll see that this is not a problem. When we're talking about something on a global scale like this, it's not a problem that can be solved by one company. And so we're looking at ways in which, what does it look like to solve this, using many different companies. One of the things that was done was, in establishing the OS Climate, there had to be a central platform that all of these various entities could tap into. You're talking about academics, banks, the asset managers, the asset owners. All of these various entities have to be able to collaborate. And it has to be done in a democratic way. It has to be done where we're attracting contributors and then also optimizing collaborations. Here are some of the members that are currently present there. You'll see there's anything from technology to infrastructure, all the way to the asset managers themselves and decision makers. Now I'm going to talk a little bit about what the platform looks like to be able to achieve this, and it has to be done in a way that's available to the public freely. If you look at this on the left side, you'll see there's various amounts of data that has to be captured. Anything from market data, sector data, all types of information from various entities. Not one single entity owns all of this. That means the data is going to be highly unstructured. It's going to be various types of data, and you have to figure out ways to link it all together. The core part of this is that there are basically some key principles that the OS Climate needed to achieve. One was that there was going to be federated governance, and there's two parts of that. One is making sure that you're federating the data that you pull together. The other part of it is that you're also decentralizing the owners of that data. You can't have it to where the data is contributed, but there's still people who claim that they own certain amounts of data. It has to be contributed in a way that can be shared for everyone. And then the ultimate part of this is making sure it's a self-service platform. We're inviting data scientists from all over the world to look at the data that's been freely available and create new models to help make those climate decisions. Next slide. Looking at it from more of a technical perspective, we have databases, we have flat files, PDFs, all this types of data, streaming data, APIs that have to be built out. All of that has to be done in a central platform. We look at open source communities that Red Hat's already invested in, such as Fedora, such as Kubernetes, Open Data Hub, all of these communities that really have been trying to solve similar problems for companies where we looked at ways to making that a foundational part for solving this for a broader good. And then on the left side of it, who are the consumers of this? You have the data scientists and everyone else that need to get access to the data. You have to do it in a self-service way because there's not one entity that owns everything. Now, the great thing is now that we've settled on what the infrastructure and the platform looks like, and we worked with various entities to do that, we're starting to get into the machine learning side of it. I mentioned before we're bringing data scientists together. Well, the cool thing about it is, seeing those data scientists work and build NLP models together. The very first thing that we're working on is taking a series of PDFs that come from various parts of the industry and using NLP collectively and building out these models. And that's a difficult thing to do because, first off, the data itself is not in the same structure. They come from various places, and we have to use these algorithms to be able to process it. And then on the tail end of it is how do data scientists together work to solve these problems. Also, the models need to be very lightweight. We're building out basically a real-time question-answer system where anyone can go in and ask a financial question for a company. What are the CO2 emissions? What's its history for carbon neutrality? And get some answers in real time. And in order to do that, we're partnering up with companies such as Intel to be able to figure out how to do things on sparsity of data. So what's next? We have to ensure that everything is transparent. The data will be challenged. As soon as you're making critical decisions like that, everyone wants to know how you're making those decisions. We need to also introduce a centralized way of doing data lineage. So as we're processing the data, there's a history of how it changed through the system. Improving the metadata, and then also improving ways in which we link data together. And I'm going to pass it over to Marius, and he's going to talk about another project called the Enterprise Neurosystem.
Thanks a lot, Sherard. And this is the next step is kind of taking what we learned from these communities. And what I'm going to talk about now is a little bit more futuristic, a little bit more forward-looking, and tries to answer a different question. We've seen what happens if multiple institutions come together and try to solve a concrete problem. The next question is, how do they come together and try to add and try to share what they learned to solve different kinds of problems, to move this, intelligence a little bit further up the stack. In the end, one of the goals of artificial intelligence is to make human decision-making more efficient. So how do we do that? How do we help in that process? And one of the observations is that technology in general has tried to reproduce nature, right? Has tried to kind of replicate the brain model, has tried to replicate biology. And we kind of picked up the brain because all the smart ideas are in the brain, right? But when you look at an organism, it's actually composed of a series of autonomous systems. And higher order functioning basically comes from coordinating these different systems. In a very, very similar way, we have a lot of data. We have a lot of systems that exist at different levels, both public data sets, for example, about different types of problems. And in the enterprise, we have different systems with different functions. We apply artificial intelligence, for example, to automate operations. And we apply artificial intelligence to do better business. And those are not necessarily the same types of models, even if they're lumped under the kind of artificial intelligence umbrella. So how can we make it possible to, on the one hand, get these systems work together cohesively and maybe apply a higher intelligence? How we work together to share the knowledge, but to share the learning from one type of system to another that's very similar. And this is one of the focuses of the Enterprise Neurosystem. The interesting thing about it is that, and you will see the list of participants, it's applicable in both public and private domains. You can apply it, for example, to understand, and I'm going to use a very big word, the functioning of the planet, but you can also apply it to understand, to have a cohesive view at the sea level on how the enterprise works. In the end, the proposed architecture, the concept of a singularity that we have here, and it's a word used in different contexts, thinks about how you allow different institutions, which as I mentioned earlier, won't or can't share their data for a variety of reasons. For competitive reasons, but also for regulatory reasons. Legally, they're not allowed to, but still share what they learn and work together better. So this target singularity architecture allows different institutions for different domains, university, research labs, cloud providers, government institutions, private institutions, to train models on their own data, share the parameters in an aggregated way, put them in a single kind of repository. Different types of models that serve different purposes, right? An LLP model, for example, is very different from an image recognition model, or a decision-making model is very different from both. But have them in a single place and figure out what's the way in which either you can share this information, you can get these parameters shared with everyone, or you can build a way to cross-correlate them all together and build a higher intelligence. And that's the focus of this effort. Now, in the kind of, when you think about it, from a different perspective, there's obviously the horizontal exchange of parameters, and everyone gets the parameters and get the models trained by everyone else and can compare with what they had and maybe improve them and share their results. But also have this, kind of hierarchical learning and acting structure, right? Where lower layers, are autonomous systems, are more focused on reporting those, more focusing on recognizing images. Once you learn, for example, that it's a cat and not a dog, then you can pass that to a higher layer that aggregates data and recognizes patterns. And then once you recognize patterns, you can draw insights from that. And as you move higher and higher up the stack, you can refine this as a higher level of abstraction and basically have, as I said, a cohesive view of the system that you're trying to observe, whether it's an ecosystem or whether it's an enterprise. And that's one of the goals of this effort. Now, of course, it's a lofty goal. That's why we need a community. That's why institutions like very varied from the Stanford Accelerator and Verizon, and you're going to see those logos in a networking company, or Red Hat with its MLOps capabilities and other companies come together to try to solve this. And how do you solve this problem? Well, with a few areas of focus. One is this concept of a central intelligence. How do you centralize these models? How you build, a self-describing library where you can put the models, understand what they are, understand what their parameters are, and moreover, understand, their lineage. Where do they come from? What do they represent? Who put them there? And of course, building the cross-correlation capability of all these models together. The other part is, it's not just about models. It's also about data. How do you allow, these enterprises to share everything, to connect with each other in a way that's secure? So, kind of elevating the, elevating the connectivity capabilities beyond the networking level and creating, the ability, for example, for me on demand to get data from Sherard, train my model, and then close that connection in a secure way. That is a big concern. Ethics and governance, as I said, very often these efforts lack, for example, legal guidelines. Yeah, when the law is the law. You can, you know what you have to do. Now, very often the ethics concerns are not very well understood, and working together to understand, to share notes, to share ideas of what it's supposed to do or not is very important. Security, for example, as I said, goes hand in hand with connection, right? Creating, enterprises are, require secure environments to run these models, so sharing ideas on that. And of course, there is another layer that's focusing on the different verticals, like telecommunications or financial services, that kind of try to bring this to, in the specific domain of the vertical. There are a number of projects that are actually part of this effort. I would say, they're trying to cover these different areas. The Stanford SLAC Linear Accelerator Lab, for example, has donated their image analytics project as a first use case, and trying to understand, for example, not only how to do better image analysis and apply it to other domains than just what they do, but also understand how you build systems, that connect to the edge, and how to do edge AI in a better kind of way, using the experience of applying that to the accelerator. The IBM research, for example, has donated their acoustics analysis use case, which is very interesting because, one of the existing projects of this effort is applying that to monitoring the bee population. and really understanding from, by doing acoustic analysis around the beehives to understand the health of the bee population, which has, as you know, a big impact on the planet. So these kind of projects are very fungible in the sense that the learning from one is applying in another area, and you can see basically the benefit of this collaboration. There's also the concern of, if we share these models, how do you know what you're getting? How do you know what's in there? So trying to reason around building this self-identified model platform is another, another active project. And finally, another example is the secure AI integration fabric, which allows, different types of workloads to connect while maintaining a level of isolation, for example, that, allows, for example, to isolate incidents and, be confident that the data that you're sharing, for example, is going to be shared only with whom you want and only for a specific duration of time. It's a community that, in many ways has originated and has been kind of nurtured by Red Hat, but it enjoys a large participation, as you can see from different domains. From the Slack laboratory, from university, and from academia, actually from the industry, from telecommunications, and we have other companies joining this effort as it goes on, as we expand, for example, to other verticals. It's, one call to action is, if this is a problem that's of interest to you, feel free to reach to us. And, obviously, it's a very, very open community. So these are kind of the community, these are the companies or institutions that's raised their hands. In summary, what you've seen is kind of a quick overview of why do institutions collaborate, why is the US climate, and two projects. Examples of that, the US climate and the Enterprise Neurosystem. And I'm going to hand it over to Sherard for the last word.
Oh, well, no, I don't have much to say there. I think Marius wrapped it up pretty good, and we'll take some questions in the last couple of minutes.
Thank you so much. I think we have time for one quick question before we move on to our next session. Thank you so much, Sherard and Marius. So time for one quick question. And here it is.
Thanks. Thanks for that great presentation. I had a question around the downstream models that are made and what kind of conversations you've had, especially at institutions like academic institutions. There's not a lot of bandwidth to give a model that's produced to the public domain. And how have your interactions been with tech transfer groups around that topic?
Well, I would say one of the things, it goes back to what I was mentioning before about licensing. It helps when things are done in a way that the license applied to it is shareable. If it's an Apache license or a GNU license, it makes it very easy to share it. A lot of times, the data itself can apply that same license and makes it easier to share. What we've seen is, especially working with other institutes, it's a little bit more challenging if there was something specifically done for their domain. But by collaborating, we've been able to work with institutes and to be able to pick apart what's valuable to the open source community and help them transition that. Red Hat's been a part of that in a number of different places. Marius, I don't know if you wanted to add anything to that.
No, I'll return the compliment. You covered it very, very well. Thank you.
All right, thank you so much.
Thank you.